Time to add our first non-backbone area to our burgeoning OSPF deployment. And here we're going to be putting area 13 into the mix. The network we're going to put in there is 172.12.13.0/27, a direct connection that I've already configured here in the lab and tested with some pings, so we're good there. And of course, this is a separate physical segment than our NBMA segment. Router 1 is using its serial 1.1 interface, router 3 its serial 1 interface, and I left the interfaces off of this one for clarity's sake. But looking at routers 1 and 3 here, are we going to have any difficulty with the rule we've mentioned a couple times about every non-backbone area has to contain an interface on a router that also has a physical or logical connection to area 0? And by the time I got that incredibly long-winded question out, you had already figured out the answer and probably taken a nap. The answer is no, because routers 1 and 3 both have interfaces in area 13, and they also have interfaces in area 0. So we're not going to run into any issues there. Will we run into any other issues? Let's go ahead and find out. If we stick with that /27 network mask, what's the corresponding wildcard mask for that? Because this is a /27 network. So /27 means, of course, the first 27 ones are set to, excuse me, there's the answer. First 27 bits are set to 1. So in a wildcard mask, that means the first 27 bits will be set to 0, leaving us 5 bits. So if the last 5 bits of a 32-bit binary string are set to 1, what do we get? 0, 0, 0, 31, right. So that's what we'll go with here. /31, got to put the word area always, and we'll go with 13. And now let's see how long it takes our typical point-to-point network to come up. Don't have anything yet, but let's just give it a few seconds, and by golly, there it is. So there's our adjacency, and frankly, I've seen them take less time than that as far as a point-to-point network goes. Now, we've got our neighbor there. Let's go ahead and run show IP, OSPF neighbor. And something you want to watch out for is when you're checking adjacencies to a given router, don't forget there's no problem with seeing a neighbor ID here more than once. And that's exactly what we should be seeing right now, because we have one adjacency with router 3 through the cloud, the NBMA network we just built, and then the one we really just built, the point-to-point network. Now, there are a couple of oddities here probably catching your eye. The first one being the dead time of the connection through the NBMA network being much larger than the one on the point-to-point network. So it looks like we have some different hello and dead time defaults for point-to-point networks. But what really catches your eye, I'm sure, is this dash. What in the heck is going on here? With all the talk we've had of DRs and BDRs and DR others, you know, in the broadcast segment we built, we didn't really care which router was the DR, but we still had one, and a BDR. Built the NBMA network, had to watch it. We wanted the hub to be the DR, the spokes to be DR others, but here I didn't mention any particular rules, and there aren't any as far as which router needs to be the DR, but this is the mystery. We don't even have a DR on that segment. Let's run show IP OSPF interface, and we'll make sure to go with that particular interface, the one we just built the adjacency with, and we get some familiar looking information, physical and logical info. There's the IP address, there's the area, there's the process ID, there's the RID, there's the network type, and it is defaulted to point-to-point as you would expect on a point-to-point serial connection, which is what we have here. Notice the hello and dead time are different. And this means something you got to watch out for, that when you build a point-to-point network using a serial interface, it does not default to 30-second hello times. What it defaults to is a 10-second hello time. That's for an OSPF point-to-point network. What we're not seeing anything about here, and what we haven't seen anything about at all, is a designated router, backup designated router election. That's because in an OSPF point-to-point network, we don't have one. And now you're thinking, you know, we've been talking about how important this election is, and now we're at a network segment type that actually doesn't have one. But let's go back to the discussion we had about why we have a DR and the role of the DR when there's a network change. You know, the detecting router notifies the DR at 224.0.0.6, the BDR at that address as well. Then the DR floods the change to 224.0.0.5. However, how many routers do we have by default and by design and by its very name on a point-to-point network? Two. You know, it's one at one endpoint and one on the other, and you know, that's why we call it a point-to-point network. Well, we don't really give that a lot of thought, but OSPF does. And OSPF looks at this and says, hey, we've got two routers on a segment. Whether one tells three or three tells one about the change, then everybody on the segment knows. So there's no reason to have a DR or a BDR. And that's why we don't have one here. That's why we don't have the election. That'll really throw you the first time you see it. It's like, what? But that's why you don't have the DR or the BDR here, is that there's no need for one on a point-to-point link. Now, I did mention on the screen, I don't think I mentioned verbally. Let's go back when I introduced this section. Notice that I said the OSPF point-to-point and point-to-multipoint networks. The point-to-multipoint network is the one OSPF network type here, the fundamental ones, that we are not going to configure here in the CCNA course because we have to stop somewhere. And the thing is, once you get into point-to-point links, then point-to-multipoint networks, there are different types of point-to-multipoint networks. So I'm trying not to absolutely overwhelm you with network types here, but I did want to mention it exists for a couple of good reasons. OSPF considers a point-to-multipoint network to be a collection of point-to-point links. So you're going to see the same thing with the DR and BDR, and you're going to see the same thing with the timers. So that's good information to have. But again, routers 1 and 3, that segment, no DR, no BDR, and we also know the hello and dead times here by default are going to be 10 and 40 on our point-to-point link. Now, let's see, what else can we do here? Let's go over to router 5. Run show IP route OSPF, and you see the 172.12.13.0/27 network. And notice that we have a different router code. And we have to get used to this, especially with OSPF, about having different router codes, because literally, I believe there are 6 we could see right here. Here's regular OSPF, and then an inter area. Then we have something called N1 types, and then E2 types. These are the only two we're concerned with right now. An OSPF destination, regular old OSPF, is a route to a destination that's in the same area as this router is. But router 5 does not have an interface in area 13. So we're looking at an inter-area route here, and that's where that IA comes from. And right now, I think what we ought to do is start sending some pings around. Let's go ping 172.12.13.1. That's router 1's interface, and we're good there, and we're good there. Now, down on router 2, we're going to see much the same here with 172.12.13.0/27. You'll notice that it is marked IA, and we can ping there. And then we'll ping .3 there, and it'll go through just fine. Now, one more oddity. This is really a real-world oddity more than anything else. Let's go to show IP OSPF neighbor. This is not something that's going to come up on your exam, frankly, but it's something I want you to get used to. With point-to-point networks, what I've noticed, especially in lab work over the years, which is where I've built most of my point-to-point networks, that what you'll end up seeing is a priority of 0 on one end of it and a priority of 1 on the other, even though we didn't change any priorities. We know what the priorities here set to 0 are. Those are our NBMA neighbors. They're the spokes, and we did that on purpose. But we didn't change this one because this is even a different interface. So even though I didn't change the priority, it is set to 0. And if we go over to 3, and you look at the priority, it's at 1. One of those oddities, I've noticed that with point-to-point links. It's no big deal, but I did want to point out to you that I did not configure this particular interface, serial 11, on router 1 to be set to a priority of 0 because there's no reason to do that. Whew, simple little link, but a lot of little things to look out for. And again, the big thing in the DR-BDR election, we have that straightened out. So we went over to router 5, we went over to router 2, checked them out. Everything was beautiful. As far as the routes, we haven't run into any issues. So coming up next, we're going to add yet another router to the mix. We're going to add router 4, and we're going to put routers 3 and 4 in an area and march on from there. So take a deep breath, and I'll see you there.